The last of our scenarios for the law of cosines is the side case. Now, okay, so straightforward, we're going to be given all three sides of the triangle, and we need to solve the triangle and give our answers to the nearest tenth, so 1 decimal. And so clearly what we need to find are the three angles. We need to find angle A, angle B, and angle C. Now, there are a couple ways to think about this. I think probably one of the best practices is this. Always find the largest angle first. Find the largest angle first. Now, how would you know which angle is largest? Well, it's a fact in any triangle, no matter what triangle we have. If this triangle is, suppose this is 5, suppose this length is 12, and suppose this length is 15. And let's just pick letters here. Let's call this, instead of A, B, C, let's call this P, Q, and R. So the question is, which angle is largest? Well, there's a theorem from geometry that says the larger angle is opposite the longer side. More accurately, the longer side subtends the larger angle. What that means is this. If lowercase q is the longest of the three sides, that means angle Q will be the largest of the three angles. If lowercase p is the middle size of the three sides, that means angle P will be the middle size of the three angles. And then if lowercase r is the shortest, that means angle R will be the shortest. So in this case, angle Q is going to be larger than angle P, which is larger than angle R, because Q length is longer than P length, which is longer than R length. So the larger angle is opposite the longer side, and vice versa. So we can look at these three sides and we can know which of them is the longest, or the largest angle. Angle A is going to have to be the largest angle. If two of them are the same, then we have an isosceles triangle, and you simply pick one of them and go with it. It doesn't matter which. So it's actually his best practice, I think, to find the largest angle first. Find the largest angle first. So we're going to find angle A first. All right? So now the question is, which law of sines formulation do we use? Well, if we're going to find angle A, not because it's alphabetical, but because it's the largest angle. If we're going to find angle A first, we need to use the formulation of the law of cosines that has angle A. Remember, if you have angle A at the end, that means you need to have side A at the beginning. And so the formulation we're going to use is A squared is equal to B squared plus C squared minus 2 times. The multipliers here are these values, B times C, and that is times cosine of, and the angle is opposite the side we started with. So that's the formulation that we're going to use to find angle A first. Once we find angle A, this is safe if we're finding the largest one first, then we can find the next largest second and the smallest third. Very often that will avoid some issues that you might not care about to deal with. Find the largest first, then the middle size, then the smallest. So angle A is given by, well, we know A squared is equal to B squared plus C squared minus 2BC cosine of A. And so plug the values in. So we have 16 squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8, right? BC is 10 times 8 times cosine of angle A. So that's, let's see, what can we have? A calculator would help if you don't know these values. 256 is equal to 100 plus, I believe that's 64 minus, let's see, that's 80 times 2 is 160 times cosine of A. And now I'm going to start to get my calculator here. I have to subtract 100 across, subtract 64 across. And so what do I get out of that? I'm going to say that is 256 minus 100 minus 64, and that gives me 92. So I have 92 is equal to negative 160 times cosine of A. Divide both sides by negative 160. So this implies 92 over negative 160 is equal to cosine of A. So what do I have here? I'm going to steal some space here. So this implies that cosine of A is equal to, what do we have here? That's 92 divided by negative 160. And that's equal to negative 0.575. And then I want to get rid of the cosine, so I use cosine inverse of both sides of that equation. Right? Cosine inverse of cosine cancels, and we're left with just A. And I need cosine inverse of negative 0.575. Cosine inverse of cosine. Remember, inverse functions applied in sequence is as if they cancel, and we're left with just the argument. Cosine inverse of cosine of A is just angle A. Cosine inverse of negative 0.575, we're going to have to compute. Since I have the number still in my calculator, I can do second function or inverse function, or however your calculator does this. I have cosine inverse of the number I just had, and that becomes, if I round this to the nearest tenth, that becomes angle A is equal to 125.1. This is degrees. So that's 125.1 degrees. All right? Notice this is an obtuse triangle, and angle A is the largest. So all the other angles must be less than that. In fact, B is the middle size, C is the smallest. Now that we found the largest with the law of cosines, now we could go ahead and use the law of cosines again, but it's simpler to use the law of sines here. It's actually simpler to use the law of sines. So if I want to find angle B, we already know angle A and side A. Now I want to find angle B, and I know side B. So I can set up the law of sines using A and B. So to find angle B, which is the second largest, so I have sine of angle A, which is 125.1. Let me write that out first this way. Sine of A over A, because those are the two that we know. And then sine of don't know yet over lowercase b. That's the one we want to find. So that implies sine of the 125.1 degrees. 125.1 degrees. Now remember that if possible, you try not to use rounded values. But anytime you use the law of cosines, there's nothing for it. You're going to use a rounded value. So there it is. I need side A is 16. And that's equal to sine of, don't know yet, angle B over lowercase b is 10. And if we cross multiply and set those equal, cross multiply this way, I get 16 times sine of don't know yet is equal to the cross multiply this way, 10 times sine of 125.1 degrees. Divide both sides by 16. Remember, do the algebra before you get to the calculator. Do the algebra before you get to this calculator. So this is sine of B is equal to 10 times sine of 125.1 degrees all over 16. And so that's going to be, I'm guessing, that's going to be a number. So I have, let's see, 125.1 degrees. So I'm going to go 10 times sine of 125.1, close parenthesis, and then divide that by 16. And that is 0.51134. Again, this is some round off error here. And so I'm going to, let's see, I'm going to need to steal some space here. I'm going to steal some space from over here. So this implies that, so let me just copy what I have there. Sine of angle B is equal to 0.51134, yada, yada, yada. Take sine inverse of both sides this time. Sine inverse gets rid of the sine function. So angle B is given by sine inverse of 0.51134, yada, 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 which is still in my calculator. So I want sine inverse, oops, try that again. I want sine inverse of my previous answer, and that is 30.8 degrees. And sure enough, that's smaller than 125. So that's 30.8 degrees. And now to find angle C, well, look, we know two of the angles. We know the three have to add up to 180. So the simplest thing to do is to simply, that makes sense, is to subtract from 180. So to find angle C, we know that angle C plus the 125.1 plus the 30.8 has to equal 180 degrees. So angle C is 180, subtract off the 125.1, subtract off the 30.8. So I can do that. That's 100, clear my machine. That's 180 minus the 125.1 minus the 30.8. And there's a little round off error accumulated, but that's 24.1 degrees. 24.1 degrees. And notice, side A is longest, angle A is biggest. Side B is middle size, angle B is middle size. And then side C is smallest, angle C is smallest. That can be a good check to make sure you've done things, at least you're on the right page here. If this is mixed up, then something's wrong somewhere. If this had worked out, if we'd worked out and got angle C to be, let's say 44, something's got to be wrong because side C is shortest. You cannot have a larger angle opposite a smaller side. So that can actually help if you find these in sequence. Find the largest first, then the middle size, then the shortest, and that will actually help you as you go to make sure your values are at least in the right ballpark. So that's our first example of side, side, side. Next video, we'll just do another example with 3 different numbers and see what we can find from there.